Hello, welcome to the tDCS Open Database. We are going to show a tutorial for how to enter data into the database. We're going to be using this article, A Nodal tDCS Enhances Verbal Episodic Memory in Initially Low Performers. There's an open access article, so you should be able to get it through PubMed. I would suggest that you find the article first, look through, try to do it yourself, and then use this recording to check if you did it correctly. So let's get started. From the home page, we're going to click Add New Entry. That'll bring us to the Create New Entry page. Here we're going to use the Auto-Populate feature using the PMID. That's the number here, not the PMC ID. We put that in the PMID box and click Auto-Populate. That'll fill out the fields of title, abstract, authors, year published, DOI, and journal keywords. If we were using an article that was not on PubMed, we could click No PMID and then fill those out manually, but it's a lot easier to do it this way. So in addition to journal keywords, which are the keywords provided by PubMed, seen here, if you wanted to add your own keywords, you would be able to do so in this keywords box. I think it's unnecessary for now, but that's just a good thing to know. If you've already read through the article, you know that it meets all the criteria for being relevant to this database. As you can see here, it has used tDCS, been peer-reviewed as it's been published in this peer-reviewed journal, tested on human subjects, reported its own original sessions, and reported meaningful dosage details. So from unspecified, we're going to change that to relevant, so it'll show up as relevant in the database. Now looking through this article, you're going to find the total number of subjects that are in the paper. Those are the number of subjects that got actual tDCS sessions, not just sham sessions. So looking in the participant section of materials and methods, says there were 44 healthy young adults recruited for this study. Again, very important that we check that all 44 of these adults received tDCS and not just sham tDCS if we want them to count as the subjects for our paper. So this paper happens to have a very helpful table where it tells us how many subjects received real tDCS sessions and how many received sham sessions. So we see 22 subjects received real tDCS. Of those, 11 were female. Other papers might not have a table like this. In that case, you just have to make sure to read carefully which subjects were in which condition. Now we're going to see which subjects had, if any, had a medical condition. If you remember in the materials and methods paragraph that we read before, it said these were all healthy young adults. So we are going to write 22 next to healthy, because all of the subjects were healthy. And we can leave the rest of these conditions blank. Now we're going to get to the first experiment. Each paper has to have at least one experiment. So let's see how many this paper has. In the study procedure, it says that all participants tested individually, and they received a nodal tDCS over their left DLPC during encoding. If you read through the rest of the paper also, you will see that there's only one type of tDCS done in this experiment. Since we only have since we only have one trial, that's easy to know. If there were multiple trials of tDCS and they changed either the current, the duration, the electrode position, or the type of tDCS, we would have to add another experiment, but there's only one experiment here. So can check under the tDCS section the parameters of the tDCS that they used. Here are those parameters. It says that it was constant at 1 milliamp for 20 minutes. So you can write 1 milliamp under current, 20 minutes under duration. You'll notice that it talks about the ramp up and ramp down phase. We do not include that in the tDCS duration. Total number of sessions, also as we mentioned before, and as is shown here in this image, each subject received 1 session of tDCS. Since there are 22 subjects, like we said before, and each received 1 simulation, that makes a total of 22 sessions. Also here, since we only have 22 subjects and 1 experiment, we're going to say there were 22 subjects in this experiment, 11 of which are female. We're given here the average age and standard deviation. There were inclusion criteria for the age range of the subject also, which we can include even though it's not in that chart. So minimum age of 20, maximum age of 30. Now we are going to get into the electrode. Here both of the electrodes are the same size. 5 centimeters by 7 centimeters, making a pretty standard size of 35 centimeters squared. Electrode 1 and electrode 2 don't have any significance by themselves, just make sure that you keep them straight. So here we're going to start, we'll make this the anode, electrode 1. It says it was placed over the left DLP-FC, centered over the F3 position, corresponding to the 1020 EG placement. So since it has a 1020 EG placement system, we're going to use that. So we can say F3, and the authors consider this nominally active since it was a nodal tDCS, and they are calling this the anode. The other one does not refer to a 1020 EEG system. We're just going to use the descriptions that the authors give, which is above the right eyebrow for its position. And they consider it to be the return electrode. Okay, and that's it for the experiment. As we discussed before, this experiment was sham controlled. So we select yes for sham controlled. There are no subjects in repeat sessions here because we define repeated sessions as more than 4 sessions a week. And there was only 1 session per subject per week. So we do 0 there and 0 there. If there were any notes, we could write that here, but there's nothing very special about this. It's a pretty straightforward experiment. And with that, we can submit. You can have this message saying that you successfully reported this entry, and an admin will check that it's sufficient and enter it into the database if that's it. Thank you so much for listening. We'll be back with maybe a more complicated paper next.